Okay, so properties of logarithms would be similar to properties of exponents. For example, if I asked you guys to multiply x squared times x to the third, you would multiply and get x to the what? Fifth. How'd you get 5? You added your exponents, right? So since logarithms are just the inverse of exponential, these are related. So our first rule is called the product rule. And the product rule says if we have the log of base b of a product. Caitlin, can you like crack my door? Thank you. Thank you. Okay, so the product rule is saying we have log of base b of a product. We have two things multiplied together. If we need to, we can separate those by addition into separate logarithms. Notice that here we have log written one time. Over here we have log written 2 separate times. With the m and the n, I separate them. And it goes both ways. So if I already have the addition, if I have separate logarithms with an addition sign in between, I can condense them to one logarithm and multiply what those logarithms are of. So I can go either way. Yes. Say it a little bit louder. They have to have the same base. Yes. They have to have the same base for that to work. Just like up here, if I did x squared multiplied by y cubed, I couldn't add the exponents because they have different bases. So they are completely related to the rules that we have for exponents. My second one, the quotient rule, let's say I had, x to the 10th over x to the 3rd. You guys would tell me that's x to the 7th because we do 10 minus 3. We subtract when we are dividing. So here the rules are consistent with that. If I have a logarithm and I'm dividing two numbers, I can split that apart to be two separate logarithms subtracting. Or we can go backwards. We can start with logarithms subtracting and combine it, condense it down to one logarithm dividing. So we go either way. The next one is the power rule. So, if I have x to the 3rd to the 4th, if I've got a power of a power, what do I do to my exponents in this case? Multiply them. So here, when I have, let me zoom in for this one. When I have log base b of some number to a power, what we do with that power is we move it to the front. You'll see it in front here. And we multiply it. We multiply that. So instead of being a power, it ends up being multiplication in the front of the logarithm. So how we were doing, what was that one that I just did? This one right here, how we were doing log base 10 of 10 to the negative 3. And I told you guys that just cancels and you get negative 3. Like the reason why you get that negative 3 and it's not a tiny little number anymore is because it goes in front and it becomes multiplication. And then these cancel out. So we get just a regular negative 3 multiplied by 1. So that's the real reason why this number is not an exponent anymore, because the power becomes multiplication. And then the last one, this last one is going to be important if you have the older calculators. If you don't have the older calculators, it might be interesting to know. But if you have the older calculators, to type in any logarithms, you have to use what's called change of base rule, which if we have log of base b of m, in order to find that answer on the calculator, we have to change the base and you have to divide. So this base right here, they just made an A because it can be any base you want. If I'm going to use my calculator, I'm going to use log base 10 because that's the one that's on the calculator. So I would do it log base 10 of m over log base 10 of b. Now the m is the big number and the b is the little base there. So we're doing the log of the big number divided by the log of b. That's how you can find this answer on your calculator if you have the older calculators, which I know some of you do. If you have the newer ones, I'll show you how to do it when we get to that part today. Okay, but that's change of base formula. It also works. We also have an ln button on our calculator, so which is log base. Who remembers what I said log base? What is ln? E. Log base E is ln. So you could do ln of m divided by ln of b. That works exactly the same as just log. Any base would work for that. Okay, so we're going to use properties of logarithms to simplify this without a calculator. So I've got log base 3 of 9 times 27. Now, I can multiply 9 times 27 without a calculator. It's just going to take a little bit of time, and I don't want to waste my time. So I'm going to use this, since this is a product, what I'm going to do is I'm going to go up here and I'm going to use the product rule. That says I can separate this to two separate logarithms, log base 3 of 9 plus log base 3 of 27. Now this should be much easier to solve. Log base 3 of 9, who knows that answer? 2 plus log base 3 of 27. So 5 is the answer. This next one is a little, it's not tricky. It's a little tricky, but it's not hard. It's a little tricky. I'm going to rewrite this, log base 5. I'm not going to write it as the square root of 5. I'm going to change the square root of 5 into a rational exponent. What does that mean? A rational exponent. That's another lesson that we've done recently. Rational exponent. What does a rational exponent mean? Somebody's saying fraction. Oh, Sarah. It's a fraction exponent. Yeah. So what is the exponent that means square root of 5? 1/2. So now I'm going to use the power rule that says to put that in front. So I get 1/2 multiplied by log base 5 of 5. And what's log base 5 of 5? 1. So that simplifies to 1/2. And that's using the power rule, even though I kind of already taught it to you. I just didn't tell you it was a property. All right. Next is condense and simplify the logarithm. Condense and simplify the logarithm. So right now I see 3 separate logarithms. We're going to condense this down so there's only one logarithm. The first thing that you want to do is kind of like the furthest thing out, I guess. I don't know if I'm saying that right. Look at each one separately. This 1/2, if I'm condensing it, I'm going to put this 1/2 back as an exponent. So I'm going to have log of 9 to the 1/2 plus, I'm going to take this 2 and I'm going to put it back as an exponent, log of 5 squared minus log of 125 to the 1/3. So that's my first step when I'm condensing. If you have a power in front, put it as the exponent. Yes. Do you mean change it to a plus sign? Yeah. Good question. So Chris said instead of making this minus and then putting a positive 1/3 here, he said, couldn't that be plus and then move the log 125 to the negative 1/3 like that? Yes. Either way is fine. Okay. But since I already wrote the minus, I'm going to go with that one. Either way is totally fine. We're going to get the exact same answer, okay? All right, now my next step for condensing would be getting rid of the plus and minus signs. So if it's a plus sign, we're going to have a logarithm of two things multiplied. So I'm going to have 9 to the 1/2 multiplied by 5 squared. If it's a minus sign, it's going to be dividing. So 125 to the 1/3 will be underneath those. So Chris, if you had done plus like that, I would have multiplied it, but it would be to the negative 1/3 power, and then that's going to tell me to put it on the bottom. So eventually we get to the exact same place. Okay, and then it also says to simplify, so let's just reduce some of this stuff. Somebody yell out, what's 9 to the 1/2? 3, good. 5 squared. 25. 125 to the 1/3. 5. So I've got 3 times 25 divided by 5, or maybe 5 divided by 25 divided by 5, 10. 15? Is it 15? Did I do my math right? So log 15 is a lot simpler than that mess that was given to me originally. Does anybody have any questions about the steps I just did? I feel like condensing and expanding is some things that each year people tend to get confused on. So this one here, if I've got a 2/3, I'm going to move it to the 8. I've got a 2, I'm going to move it to the 5. So I'll have, I don't even know why there's a 10 here. We're not going to write that. Log 8 to the 2/3 plus log 5 squared. So now I condense it to one logarithm. 8 to the 2/3 multiplied by 25. What's 8 to the 2/3? 4. So I get log 100. Is that as simple as I can make this one? It's not. Why? I couldn't hear you with the eye roll. Can you do it again? It can go to 2. Is that what you're saying? The answer becomes 2. Yes, because the base is 10, and then 100 is 10 squared. The 2 comes in front, and those cancel, and we get 2. Good. All right, so to use the change of base rule to evaluate each of these, you would just pick any base you want. I'm going to use 10. And we will do log, big number, divided by log base. And you have to use your calculator for this. So go ahead and grab your calculator. And then I'll also show you how to do it if you have the newer calculators. But go ahead and type that in so we have a reference of how to get this correctly. You should get approximately 1.2091. If you did not get that, let me help you. It is just on this first column. We're gonna know something cool. I didn't say this into the microphone though. If you look, actually, I can open up my calculator and we can look at it there. So I got to open it for the next thing anyway. If we look at the button log, and then you guys look above it. So if you had to hit second log, what is it giving you if you have to hit second log? So here's the log button. I'm doing log 7 divided by log 5. 1.2091-ish. What is right above the log button? It's inverse, 10 to the x. And look at the button underneath, ln, and look what's right above it. It's inverse, e to the x. Look at the button right above it, x squared. And the inverse of that is square root. It's kind of cool. Not all the buttons are like that, but those are. Okay. If you have the newer calculators and you go to math, and then I actually scroll up, you can keep scrolling down if you want, but there is a log base button, and it will actually allow you to put in the little 5 and the 7. Sometimes even though I have the new calculator, I still use the change of base formula because it's faster for me than to go under the math button, but either is fine. But if you have the older calculators, you can only do it the one way. So yes, dear. Then you don't have the older one. The older one has a yellow, yours isn't that old. The one that doesn't have fractions on it. So if you hit alpha y equals and you can do a fraction, you don't have the older calculator. Okay. And that is another way you could do it. You could do, your log 7 over log 5 this way too. And just to be fancy and to be different, if you wanted to do ln 7 divided by ln 5, it's still going to give you the same answer. Okay, so change of base formula for the next one. Change of base formula. I would do log of 3/7 over log 12. So go ahead and type that in your calculator however you want. And you, after rounding correctly, you should get negative 0.3410. Any questions on that? Okay. All right, use properties of logarithms to solve each equation. In order to solve the equation, you cannot have separate logarithms on one side like what we have right here. So we have to condense them. So in order to solve this equation, I can only have one logarithm on this left side. So I look in between the logarithms and it's addition. So what should I do to this stuff to make it one logarithm? Multiply. Okay, so I multiplied it. If you can't do that in your head, you could draw the grid or you could FOIL. And that's what I did. Okay, now we're going to solve this equation and I need to get rid of a log of base 7. So what is the inverse of a log of base 7? 7 to the, does anybody remember that term that I said that you do to both sides when you do 7 to the? It starts with an E. Yeah, exponentiate. Exponentiate both sides. So we're going to do 7 to the on both sides. 7 to the is going to cancel those, and we have x squared plus x minus 6 equals 14. Still have to solve it. How do I solve an equation that has an x squared and an x in it? I'm going to try to factor it. So I'm going to make it say equals 0. What if I can't factor it? Quadratic formula, or complete the square if you want. This one factors x plus 5, x minus 4. What do you think? Think that's it? Or should we maybe check our answers? No? If I plug -5 in, if I'm checking my answers and I plug in -5, I will have log base 7 of -7, and I'm going to stop right there. There's something that I said that you can't do. You can't take the log of a 0 or of a negative number. You can't do it. So guess what? That's not an answer. So I do need to check my answers. If I plug in 4, I will not have any negative or zeros in there. So I should be fine with this one here. Yes, dear.
My brain can't comprehend. How do you get like -7 from that? Like
Oh,
the -5? Like,
right here, right here.
Yeah.
I'm just doing -5 minus 2 in this spot here. I just plugged it in. Yeah, that's okay. Oh, were you doing this one here?
Yeah.
I mean, we could do that one too. 49. See, it worked there though. I don't think it's an answer. Let me go. We're going to double check a different way now that you've said that. How do we do a log base on here though? Okay, help me out. Was it x minus 2? Okay. And then it was plus, same thing. Thank you. And then we were trying to find that when it was equal to log 14, right? Base 7, 14. Y equals. Right. So there's only one place that it actually works, where the two sides of the equal sign are equal to each other. You can see at -5, it's not an answer. So there's another way you could check it if you had Desmos handy. And you can check it on your calculator too. It's just going to be more complicated, especially if you have the older calculator, because you'd have to type in that log base 7 of x minus 2. You'd have to type in as a fraction, if you had the older calculator, log of x minus 2 divided by log 7, because you don't have that little base thing on the older calculators. Okay, back to the notes. So here's a second one. And we're going to condense this so we don't have two separate logarithms. So I'm going to have a log base 2. But what do I do with this stuff when I have a subtraction sign? using our properties that we just went over. We divide. So we will have x plus 1 over x minus 4. Now I'm going to get rid of the log by exponentiating. I'm going to take both sides to the whatever was there before. So these will cancel. And I will get x plus 1 over x minus 4 equals 2 to the third is 8. Now we just have an equation to solve. How could we solve this one? Wait, what? Oh, I don't know where I got that from. Somebody tell me what happened in my brain just now. Okay. Cross multiply. Or multiply both sides. Cross multiply. So let's see. X plus 1 equals 8x minus 32. Now we've got an equation you guys should be able to solve. That has a really nice looking answer. Did I do any math wrong, or is that the answer? You guys are still catching up. Okay. I'll type it in. Minus 4. Is that what it is? Somebody? Thank you. So I got 4.02. Then my answer doesn't look right.
It's supposed to be 3.
What's 3?
Oh, just kidding.
Wait, it's the other side. No, it's the other side is 2. Not 3. Right, not 8.
It's 3.
It's 3. That's what you're talking about. 4.714. So is that the same thing as 33/7? Yes. So then we did do it right. Okay. Sorry. I hate going back and forth because I have so many tabs open. That's why I'm like, tell me what it said. I forget. And then I forgot. All right. So that's partially what you guys are going to do today. And then the other part is you have to download the notes from today. It's just a teeny bit more. It's not that much more. So if you haven't downloaded the notes from today, go download those right now. I'm going to stop this video. Nah, I'll just download it right now. I'm just going to keep going. No, I'm going to stop the video. I can't make up my mind.